Hi guys, here we're looking at the inverse of a 3 by 3 matrix. The formula is at the top of the screen. You can see it up here. Oops, that's not the highlighter. Let's grab that. And aside from the 1 over determinant term here, it doesn't really look that nice. Technically it is the same formula as the inverse 2 by 2's. Just doesn't seem like it just yet. Now, there are a lot of steps, and the first step is by far the most time consuming. I will try and break it down as much as possible. Once you've practiced this a little bit, you might be able to combine some of the steps and take a lot less time to finish that process. All right, let's have a go. So here's my matrix, 153420012. The first thing that we're going to do is find the matrix of minors. Now, a minor is the 2 by 2 determinant that you get when you ignore the row and the column of each term. So we've done some of this within the determinant calculation. Now, I'm going to make my matrix pretty big here. I'm going to write it all out in full. You probably won't need to do this when you're working this out. So for the top left term, I'm going to ignore the row and the column, and I'm going to consider this 2 by 2 matrix here. I'm going to work out the determinant of that. Now you might already be able to see the determinant is going to work out as 4, I believe, but I'm just going to write the calculation in full for now. We're going to continue that, so we're going to do that in a total of 9 times. So bear with me on this little bit. All right, let's start evaluating these 2 by 2 determinants. So in the top left, I've got 2 times 2 take away 0. That's going to be 4. Here I've got 4 times 2 take away 0 again, which is 8. Over here I've got 4 times 1. There's another 0. That's super convenient, so that's going to work out as 4 as well. Over here, more workings. 5 times 2 is 10. Take away 3 times 1 is 10, take away 3, which is 7. The middle term, 1 times 2 is 2. The other term gets multiplied by 0. Here we've got a 1. Down here we've got 5 times 0, take away 3 times 2, which is going to work out as minus 6. This term is going to work out as 1 times 0, take away 3 times 4, that's minus 12. And this bottom right term is going to work out as 1 times 2, take away 5 times 4, that's 2 take away 20, that is going to work out as minus 18. Great, so that is step 1 done. That is by far the most time consuming step. The rest of it will hopefully be a little bit quicker than that. All right, let's talk about step 2. Oh. So I didn't even mention the determinant. I realized it was written down afterwards. So we should probably do that now. So to get the determinant, you can have a look back at the previous video if you can't remember, but we're multiplying each term in the top row by its corresponding minor matrix, and we're going to alternate the signs. Now, fortunately, we've already done the calculations for the 2 by 2 determinants as we've gone along here. So this will be a little bit quicker than it would have usually been. So it'll be one lot of 2002, which I've already worked out as 4. Take away 5 lots of 4002 plus 3 lots of 4201. And I'm just getting these 3 matrices. Oh, my voice is going. Getting these 3 matrices from here. 1, 2, 3. Now I know the results of each bit here. I can see them here. They are 4, 8, and 4. Oops, got carried away with the 4 there. So my determinant is 4, take away 40 plus 12, which is 4 plus 12 is 16, take away 40, it's going to work out as minus 24. That's my determinant. Okay, now we're okay to move on to step 2. Okay, so here is step 2 coming up. We're going to apply effectively a checkerboard of pluses and minuses, like so. And that's just going to change the sign of some of the terms in the matrix. Right, so if I just jot these in again, but with some changes of sign. And I include my terms in front, so 4, 8, 4, 7, 2, 1, minus 6, minus 12, minus 18. So all that's going to happen here is the terms here are going to have their sign changed. So let's get the matrix of cofactors. We're going to have 4, minus 8, 4, minus 7, 2, minus 1, minus 6. Bottom center term minus and minus is a plus 12. Sorry, that's my printer. And there we go. That's our matrix of cofactors, and that is step 2 complete. Okay, here is step 3. We're going to transpose the matrix that we got at the end of step 2. The transpose, you can see a little T here. Effectively, what transposing a matrix does is it swaps the columns and the rows around. So this first row here, the 4 minus 8, 4, is going to become the first column. So we're going to have those values, 4, minus 8, and 4, going in as the first column instead of the first row. We'll repeat that process, so the second column is going to match the second row. We're going to have minus 7, 2, minus 1, and minus 6, 12, minus 18. That's step 3 done. Okay, so before we properly move on to step 4, just to give you the terminology, this matrix is known as the adjugate matrix. So going back to the original expression for the inverse, the formula was 1 over the determinant times by the adjugate matrix. The adjugate is what we've got here. So the matrix part of the calculation is done. And we did actually work out the determinant as well. It was minus 24. So let's stick it all in. Minus 1 over 24. Here's my matrix. 4, minus 7, minus 6, minus 8, 2, 12, 4, minus 1, minus 18. And there it is. Let's color it in. Don't worry about going in the lines. There we go, happy days.